Hey guys, this is Miss Chocolate. Today I'm come back with the simulation of the titration. This is from the site Chem Collective, and it's the experiment about determining the concentration of an unknown HCl solution using NaOH and solid KHP. To say the brief thing, it gives that the concentration of HCl and NaOH is between 0.1 mole and 1 mole. So first, in this experiment, we should figure out the concentration of the NaOH by using the KHP. And then using that concentration of NaOH, we can find the unknown concentration of HCl. To briefly, I already made this procedure for the two parts of experiment. So first, in determining the concentration of unknown NaOH by titrating KHP, first we will add 3.5 gram of KHP in a conical flask with 100 milliliter of distilled water. We add the 100 milliliter of water because it is the solid, and you can, this is the just random number of the gram that I chose, but you can use 5 or 6, anything you want. But you have to remember that if you add much of this KHP and less water, the concentration will be high. Then it takes more time to finish, reach the end point of the titration. So it's better to be less, I guess. And then after that, we add 0.5 milliliter of phenolphthalein in KHP equation. This is because we want to see the color change from colorless to pink when we add NaOH solution in the KHP solution. And then we start the titration by filling 50 milliliter of unknown concentration of NaOH in the burette, and then measure the initial volume of the NaOH in the burette and then titrate with 0.01 milliliter to each KHP. And when the color changed from colorless to pink, which reached the point to stop the titration and measure the final volume of the NaOH. And then repeat this experiment 2 times or 3 times if you want, to 1 to 5 this procedure, and calculate the average molarity of the NaOH. And second part is determining the concentration of unknown HCl solution by titrating with a known concentration of NaOH. So before the part 2, we already know the molarity concentration of NaOH. So we use that in here, and we repeat the same, similar procedure with the part 2. So first we add phenolphthalein with the concentration of HCl, and then fill 50 milliliter of NaOH in the burette, titrate, and measure the initial volume of NaOH and the final volume. And the color changes, stop the titration, okay? And then repeat this experiment two times more, or 1 to 4. Calculate the average molarity of the HCl. Then the experiment is done. So let's start. I will first use the eliminators. We add this one, and then we go to stockroom solutions. KHP is in here. We add like this. Oh, before the start, there are 3 versions in this experiment: precise version, signature figure version, and realistic version. Realistic really depends on our senses. So I should hold to pour this like this, and you can see that this is very inaccurate. Okay, so I'm not gonna use this. And this one also, we can use it, but it might be more appropriate for the IA things. Yeah, or reports. But in this experiment, to clarify and to get the accurate, the number of the molarity, I'm just using the precise one without the uncertainty. Yeah, so since I use the precise mode, I'm not gonna repeat this experiment twice or like several times. I'm just gonna tell you guys how to do the experiment. So yeah, remove this again. We can remove the solid, so it can be 0.0 milliliter again. So I would add 3.5 gram here, precise mode, then, and they said, yeah, 3.5 gram is transferred, okay? Then I can remove this, and add 100 milliliter of water, right? As I said, 100 milliliter, yeah, distilled water. For it seems like this. You can remove this. Then you can also rename this without to prevent the confusion. So I can say, what is this? KHP, yeah, 3 gram plus, oh my god, 3 gram plus 0. Oh yeah, I almost forget this. To see the color change, I should add the phenolphthalein here. I will only add 0.5 milliliter here. Yes. Then I can remove this. Rename this by KHP 3.5 gram plus phenol 0.5 milliliter, like this. Okay. Okay, so this is the solution is made. Then we should use the burette. Burette is in a glassware, not in here, but others. You can find the burette in the last. And then, yeah, you can add NaOH. The concentration is unknown. This doesn't mean that the concentration of NaOH is 1 mole, but it's between the 0.1 mole to 1 mole, maximum 1 mole, as the question said. So I will add maybe 50, right? So I will add 45 first. Yeah. Then I can remove this. Remove. And rename this unknown concentration. Yeah, 50 milliliter, 40 milliliter, 45 milliliter. Okay. Then everything is ready. And yeah, I can start the titration. But we have to measure the first titration volume. It is 7, right? So I made a table for here, table 1. So we first add 3.5 gram. We haven't calculated this one. Initial volume of the burette is 7, right? 7. Because we can precisely, accurately measure only 0.1 interval, I use 1 decimal point here. 0.1. And started pouring. I think it might took a long time, but yeah, because this is the first time, I should do it individually. Quick. You have to see really carefully that this one, the solution, it changed color to pink when it reached the point. And if you click once or twice more, when the color already changed, your data will not be accurate. So you should, oh my god, I miss it. Oh, okay. So this is the things that you might do. So don't just talk, to just concentrate on the color change, okay? Yay, once again. So so 0.1. Now I'll concentrate in here. Oh, look. I think I click once more. So it should be 24.8. Okay. I hope I got right. I hope I only clicked once more. Okay, 24.8. 24.8. Volume of NaOH. So if we subtract from the final to the initial, we get 737.8. Okay, then we now have to calculate the molarity of this one by using the rules up here. So the calculation part. So part one, calculate the number of moles of KHP and NaOH. We know that molar mass of KHP is 204.22 gram per mole. You can Googling this one, or you can add all of the the atomic masses of this using your data booklet of chemistry. So I just Googled it from the, and it shows like this. And we know the number of moles is calculated by mass over molar mass. And we know the molar mass is here. And mass, we put 3.5 gram, right? 5 gram. So we can calculate the moles. I will do it. 3.5 divided by 204.22. Yeah, it's 0.01714 by rounding. Yes. And you know, this is the equation of the NaOH and the KHP solution, and you can get this equation when you search in the Google. The ratio of the number of reacting moles between KHP. This is the KHP. So this is 1 to 1, right? That's the number of moles of reactant NaOH is equal to that of the KHP, which means this is same with this one. So I will add here like this. Then the molarity of NaOH solution is determined by the titrated volume of what milliliter we said? 17.8. 17.8 milliliter in here. Shown in table 1. Molarity, number of moles. We solve the number of moles, which is equal to the number of moles of KHP. We copy this one. And then, since the volume of the NaOH is used in milliliter, and the molarity is the volume of solution in a liter, we should times 10 to the power to the minus 3. So 17.8 times like this. When I calculate this with my calculator, I got 17.8 times 10 to the minus 3. And I got 0.9696 or 628 here until for the four signature figure. I'm trying to use the four signature figure because they want the answer as for the four signature figures. But yeah, this is all about because I use the random things, not without the what is that? The constant signature figure, because this is just to show you guys. But if you want to write IA or the formal report, you should make sure that you have this constant significant figure or decimal point. Yes, and yes, we got the molarity of the NaOH, this one. And this is right because it is between the 0.1 mole and 1 mole. So we can say here 0.9628. The morph moles was 0. Like this. Because once again, because I used the precise mode, I'm not going to repeat this one again. But if you guys doing the other modes, you should try 1, try 3, and 4, 5 several times, and then add all of the molarity that you get, then divide it by how many times you repeated, then you can uh, calculate the average molarity of NaOH. But I'm gonna use this one because I think this is precise, and this is precise mode. So this first experiment is over, so we're gonna do the second part in the next video. I hope you guys enjoy this journey, and don't forget to click like and subscribe. Thank you for watching.